Our next example is this x squared minus 20x plus 120. Now in this case the coefficient of x is minus 20. So x squared minus 20x plus 120, we can take coefficient of x which is minus 20, half of it is minus 10. So you square minus 10 and then subtract. So minus plus minus 10 squared minus minus 10 squared. So first three terms, these three terms could be taken together as a complete square. So x minus 10 squared, here minus 10 squared plus 120. So remember this minus sign always comes in, this minus square thing always stay outside the bracket. So this will be reduced to uh, x minus 10 whole thing squared plus 20. Therefore, x minus 10 whole thing squared plus 20 is the complete square format of x squared minus 20x plus 120. Let's move on to another example and see. Example number 7. P squared plus 14p minus 3. I hope you can do it by this time or by yourself. So, what is the coefficient of p term now? That is 14. Half of it is 7. So you square it and then subtract. See, square it and then subtract. I think you can do it all by yourself. Now you you take first three terms, and write it as a complete square. Always the added part goes inside the bracket and the subtracted part will stay outside. So this sign comes here, p plus 7 squared minus, so always half of this comes here and square, and the additional square will be reduced here. So this will be the complete square format of this one. P plus 7 squared minus 52 is the complete square format of p squared plus 14 minus 3. We will quickly go to the example number 8. But there are quite a few examples I am discussing here. And look at this, b squared minus 9b minus 2. Here I have used different letterings, a, p, b, t, s, all these things, just to give you an impression that anything could be used. Later on it will be converted only to x, but here you will understand anything could be used. Look at this, half of it is 9 over 2. Right, in the early example also I multiplied and showed you half into 9 is equal to minus 9 over 2. So look at this, minus 9 over 2 squared you added and then subtracted minus 9 over 2 squared. And then the first three terms, these three terms will always go inside the bracket as a complete square. So b minus 9 over 2 whole thing squared, this minus 9 over 2 squared comes here, and we can simplify this in this manner, 89 over 4. Now I will explain you this 89 over 4 back again, and those who are finding it silly, please excuse me, bear it up for this. 81 over 4 minus 81 over 4 minus this one will be minus 2 to 8, then it will be 8 over 4. Minus 2 could be written as 8 over 4. I wrote it into a common denominator. So this is minus 89 over 4. This is how I simplified this. Okay, this is a very simple thing. Right, we can move on. So this is the complete square format of the other. This is the complete square format of this one. You can write it like this. Okay, let's move on to another example. Example number 9 will give you something like this. Again, f squared minus 7f minus 4. So half of the coefficient is minus 7 over 2. You square it and then subtract. So these three terms will come inside this. So and this one. And then you can simplify this back again. This is 49 over 4. This will be minus 4. Then it will be minus 16 over 4. So 49 minus 16 will be 65. Right? So we can write it like this. This is the complete square format of this one. Right? This is the complete square form of this. You can see it very clearly now. We did quite a few examples and we'll go to another example. This example give you it in this way. There's a fraction here for C and this minus 11. Then when it is minus 11, half of it is minus 11 over 2. You add then square it, add then subtract. So these three terms will come inside the bracket, right? This one. So we will simplify this in the same manner we did. So this is 121 over 4. This is minus 5 over 4. Then this will be 125, 26 over 4. So this is L minus 11 over 2 whole thing square minus 126 over 4 is the complete square format of this one. I think you got it very clearly. You can replay this and see. Yeah. Let's go on to the example number 11. This time this d coefficient is a fraction, right? Now what is half of there you are. Half of this is 1 over 8. Half into 1 over 4. Half into 1 over 4 is 1 over 8. So you take 1 over 8 and square. And add then subtract. Add then subtract. Right? Then these three terms could be taken as d minus 1 over 8 squared minus 1 over 8 squared plus 4. So this could be simplified as this d minus 1 over 8 squared plus 255 over 64. So this is the complete square format of this one. This is the I have written it in each and every one in this manner. I think by this time it is quite clear for you what's happening here. Again I will take another example. Here also there's a fraction here, r squared plus 1 over 3r minus 2. Half of this is 1 over 6. You square it and then subtract. So take these three terms together, r plus 1 over 6 whole thing squared minus 1 over 6 squared minus 2, sorry. And then we can simplify it in this manner. I think you understood how to do this simplification by this time. So yeah, this is the complete square format of this. We will quickly move on to another example. Example number 13. Let's see. 5 over 3. The coefficient of x is 5 over 3. Half of it is 5 over 6. Actually minus 5 over 6 because this is minus here. Minus 5 over 6. You square it and then subtract. Square it and then subtract. So addition only always go inside the bracket. So it will be x minus 506 squared, this one comes here, and this is minus 506 squared plus 3. This is then 25 minus 25 over 36 minus 25 over 36 plus 3 will be 83 over 36, right? This is the complete square format of this one. So that is now again simple. We'll quickly move on to another example. Now this time there's a small difference. All this time the coefficient of k, the squared term was 1. But in this case there is a coefficient in front of that also. So to bring it to complete square format, first of all we will make this coefficient of k squared 1. In order to do that, only thing we can do is to pull out this 2 from this expression. There you are. Now I have pulled this 2 out. So each and every term inside this will be divided by 2. When you divide by this one by 2, it will become 1. This will become minus 3. This will become 7 over 2. So you have seen, can you see it now? I have taken this 2 out to make the coefficient of k squared 1. So now it is the same process while this 2 is lying outside. So 2 is there, half of this is 3 over 2, right? So we have not written the minus here, it's okay since we are squaring, right? 3 over 2 squared minus 3 over 2 squared plus 7 over 2. These three terms will go inside the bracket in the complete square, and then these two will be simplified. So it will be k minus 3 over 2 squared. Now see, note that this 2 is lying outside, and then 3 over 2 squared this is 9 over 4, this is 14 over 2, then that will be simplified as this 5 over 4, right? Now you can open this bracket by multiplying each and everything by 2. So I will take it to this side because I don't have space. 2 into this one and 2 into this. So when you multiply this, it will be 5 over 2. So this is the complete square form of this one. This is the complete square form of this one. Right. So here the difference was there was a 2 in front of this square term. So in order to complete square, first of all we pull that guy out. That's all. We look at another example. In this also there is a coefficient in front of it. That is 3. So we will take the 3 out. Then we will divide each and every term by 3. So this will be x squared minus 4 over 3 plus 3, 5 over 3. This 3 is lying outside. Now the coefficient of x is 4 over 3. When you take half of it, it will be 2 over 3. So you square it and then subtract. 2 over 3 square. Right? I think you understood how did I get this 2 over 3. If I try to explain you here, it's a bit of a problem because of this pointer. Half of 4 over 3 is 2 over 3. There's a minus here, therefore we'll put a minus also. So that 2 over 3 only came here. There, look at this. Added and subtracted. Okay. These three terms will always come inside. Right? Okay. These three terms always will come inside. Right. it is like this now, right? This 3 is always lying outside until we finish the whole process. This is these 3 terms is, this is minus 409 and then plus 304, then it will be this, so this will be 1504, then 11/9, right? You multiply this 3 inside the bracket. Now I take it to this side because I don't have space here, and then you get this one. You multiply both these terms by this 3 lying outside, then 3 into this and 3 into this, then this could be simplified a little more. So this is the final complete square form of this particular quadratic equation. Okay, now we'll move on to another example. Example number 16. Right, this says no C part. It's okay. Half of first of all you take 6 out. This is 7 now 6, right? You divide each and every term inside this by 6, then the 6 is lying outside. Half of this is 7 over 12. Then you square it, add and subtract. There is no constant term to be carried here. So 6, this could be, this is the complete square form. Then you multiply this 6 into this. 6 times this one and 6 times this one. So it will be finally, this is the outcome. So we will, this is the complete square form of this one. Right, we will see with another example. Example number 17, something similar to that one. So here this time 3 has to be taken outside. So we take 3 out, then 503, the half of it is 506, square it and add and subtract, and then do the same thing. I think you can understand what's happening here. This is this. Okay. We'll go to the another example quickly. Here also, what is common here? Minus 5 is common. Take this minus 5 out, then y squared 4 over 5, right? And then 2 over 5 is the half of this. You square it, add and subtract, and these 3 terms will be taken inside the complete square form. So this will be 4 over 25. Then you multiply by this 5 here, minus 5 here, then minus 5 times 5 minus 5, 205 whole thing squared. This minus will become plus when you multiply by this. This will be plus 5 into 4 over 25. You can simplify here in this form. So this is the complete square format of this. Right. We'll take another example and see. Example number 19. Here what is common? We take minus 2 out. So minus 2 d squared minus 5 over 2. This plus will become minus because I have taken the minus out. This plus also will become minus, I have taken. So divide everything by 2. Actually minus 2. Then half of this is 5 over 4. Right? 5 over 4 squared minus 5 over 4 squared. And then these 3 terms will be written as d minus 5 over 2, 5 over 4 whole thing squared. this is 25 over 16, this is minus 8 over 3 over 2, and then this can be simplified as this. So open the bracket here now. Right, this minus will become plus, this plus will become minus because I am multiplying by minus 2, and then this will be simplified 49 over 8. So this is the complete square format of this one.